Suppose an electron chasing a proton up to this page. Electron and proton, they are moving in the same direction. Chasing means they are moving in the same direction up to the page. Yani both velocity directions are up to the page. Proton and electron goes in the same direction. When suddenly, when they are moving up to the page, suddenly a magnetic field is pointing into the page, yani cross, applied. What would happen to the particles? So when velocity is perpendicular to the page, magnetic field is perpendicular to velocity. If the magnetic field and velocity perpendicular to each other, maximum magnetic force acts on the charges. And magnetic force acts on the charges. This magnetic force direction can be found by using right hand rule 3. So 4 fingers into the page, into the board. My pen is representing the direction of the charges, force acting on the charges. One of them is on the right, on the left, and one is on the right. So back of my hand is for electron, palm is for proton. So velocity is going to be time is going to be velocity direction. Now when I apply right hand, I see that proton force acting on the proton is going to be to the left. Force acting on the electron is going to be to the right. So can they move in the same direction right now? No. Impossible. They will change their direction in direction of the force. In which direction force acts? So force acting on the electron is to the right. That's why electron will deflect to the right. Proton will deflect to the left. And they are going to follow, remember, arc, circular arc.
Yes.
One of them will do like this. The other one will do like that. And when a proton and electron, when they enter inside the same magnetic field and move in the same direction, they always deflect in opposite directions. Or opposite. If two particles, when they enter inside the magnetic field and move in the same direction, deflect in opposite directions, absolutely they are opposite charges. One of them is positive, the other one is negative. But if they deflect in the same direction, both are same. Maybe both are positive, maybe both are negative. Okay, notice they can ask question in the reverse way. This is asked in ministry this way. So answer was electron will go to the right, proton will go to the left. It was the choice in the teacher's book, and then they give this answer in the ministry exam as choice. Okay. Now question number 10. Why did I put question number 10? Because it is related to 11. 11 and 10 are so close to each other, but 11 is asking in opposite way of the 10 is asking opposite way 11. Okay, now let's do 10. Two charged particles are projected into a region where there is a magnetic force perpendicular to their velocities. Yeah, they're projected means they are moving in the same direction. Magnetic field is perpendicular to their velocities. Can like this one, into the page or out of the page. If particles are deflected in opposite direction, if particles are deflected in opposite direction, their sign must be different sign. One of them must be positive, the other one is negative. Evet. Gördüğünüz gibi this one and that one, 10, 11 and 10, in fact, very close. Alright, now 12. Question number 12. Why does the picture on the television screen become distorted when a magnet is brought near a screen? But to know these television screens are old-fashioned televisions they are talking about. Old-fashioned televisions are using magnetic field. And that inside story which is cancelled was about that. Magnetic field to change direction of the electrons, because electrons are first accelerated by electric field, then start to move towards the screen. As they are moving towards the screen, magnetic field is changing their direction. They are colliding different parts of the screen and make a picture. Old-fashioned televisions, yani these black-white televisions. But if you use an external magnet, what happens? You are going to add one more magnetic field. And each magnetic field causes a direction change. So when you make magnet closer to that, direction of the particles will change. That's why your mouth is going like this. Like this. It will change. Reason is that external magnetic field will also affect the charged particles which are moving inside this cathode ray tube. Cathode ray tube in the 10th grade chemistry, I think you learned that. In television, they are using these cathode ray tubes. Electrons are projected from cathode to the going one direction. Magnetic field makes their direction to change. But if you use another magnetic field from outside, they will change once again their direction. They will go wrong place, which will make a wrong picture of you, which is called distorted. Distorted means that picture is changing little, very little, because of that external magnetic field. You make it close to the television, okay? But new televisions are not like this. New televisions are using different techniques. It's about old version televisions. And question number 13. A proton horizontally enters a region where there is a uniform magnetic field perpendicular to the proton's velocity as shown in the figure. I think this is the last, this one. Describe the proton's subsequent motion. How would an electron behave under the same circumstances? Yes, proton is entering in the magnetic. You can use right-hand rule here. Magnetic field is into the page. For proton is the pulse is the magnetic force. As soon as proton enters this magnetic field, a force acts up to the page, which will cause direction change of the proton upwardly at counterclockwise arc. Another method, remember, was this positive and cross counterclockwise arc. But the answer is given in the cheat sheet in terms of position from where they will live. This proton will live this magnetic field from a point above the point of entry. Here it says point of entry. So then it will live from a point above point of entry. But it were an electron, it would deflect in opposite direction. It would live from a point below point of entry. It will be answered in the classroom this way. Okay. Question number 14. Two parallel wires carry electric current in opposite directions. Explain why two parallel wires carry parallel current carrying wires, current wires. Two parallel current carrying wires in opposite direction repel each other. Why do they repel each other? In fact, we explain it like this, remember. For any field force, not only for magnetic field, electric field, gravitational force, gravitational field, if there must be a force, there must be two fields. Two fields. One magnetic field requires another magnetic field to produce a force. One electric field requires another electric field to make a force. One gravitational field requires another gravitational to make a force. We need two fields. These parallel wires, each of them produces a magnetic field around. Magnetic field around. Yani, first wire produces a magnetic field around. Second wire produces a magnetic field around. Each wire is inside the magnetic field of other wire. Yani, each wire is using other wire's magnetic field as external magnetic field to produce a force. Now, these are two wires which carry electric current in opposite directions. So, the one on the left produces a magnetic field, external magnetic field. According to right hand rule, it's going to be circulation is like counterclockwise, if you look that way. So on the left it is out, on the right it is in. Second wire is inside this magnetic field, which is electric current down to the page. Then apply right hand rule 3 for finding the direction of the force. External magnetic field is cross. Electric current direction on the second wire is down to the page. So look at the palm. Palm goes to the right. So that's why this wire will be pushed by the first wire to the right. There can be different ways of explanation, but your book explains this way. Yani one wire is inside the magnetic field of the other wire. Each wire uses other wire's magnetic field as external magnetic field. According to right hand rule 3, we are going to find direction of the force on each wire, and we will answer the question. Can a stationary magnetic field set a resting electron into motion? Bunu konuşmuştuk. And a resting charge, yani stationary charge can be made into motion only by electric fields. Stationary magnetic field. Stationary. What if they say it's not stationary? Yes, it is possible. It is possible. This is advanced physics. But variable magnetic field can also make charge into motion if it is not stationary. Yani not uniform, not constant. Yes, electromagnetic waves have a magnetic component which is changing by time. Changing. And this magnetic field, changing by time, can set charge into motion. Yani vibration yaptırabilirler. Ama this is talking about what? Yani constant, uniform magnetic field. Constant, uniform magnetic field cannot set a resting charge into motion. What should we do? We should use a electric field first. After that, if we want to force act on this charge, you can set into a magnetic field. All right, question number 16. At a given instant, a proton moves in positive x direction. This is the set. Positive x, negative x. Positive y, negative z, positive z. In a region where there is a magnetic field in negative z direction. So velocity is positive x, negative z is magnetic field. So angle between them is 90 degrees. So maximum magnetic force acts on the charge. What is the direction of the magnetic force? A magnetic force is always perpendicular to B. Always perpendicular to B. B is along z-axis, B is along x-axis. What is left? Y. Force must be along y-axis. Positive y or negative y, we are going to apply right-hand rule. So this is a positive charge, so palm is going to be the magnetic force direction. In which direction magnetic field is?
Down.
Negative z. I'm going to show negative z like this. Negative z, huh?
Yes.
Then palm is going to be positive x. Yes, it is. Look at the pen. It goes positive y. Yes. Magnetic force is going to be positive y. Maybe this can help you for answering your question. If we table up, if let's say table, we have Q, V, B, and F. If V and B, X and Y, Z, absolutely. Z is going to be the upper one. If B and B, X and Z, F is absolutely Y. If B and V is Y and Z,
X.
V X will be X. How positive and negative can change. You can also, by using right hand rule, you can find them, but this is always correct.